Now, up until this point, these were all things that you really don't need any type of documentation to do. You can pretty much figure this out on your own, all of those things I just showed you. But if you want to get more into detail, like let's say there's a problem you have to troubleshoot, or you need to know a part number for something, or you may need to know how to adjust or align something, it always helps to have a service manual. Now, there are many places you can search with the internet today to find a service manual. And for gear of this generation, okay, this age, no matter if it's Pioneer or Sansui or Marantz or Kenwood, you go down the list. One of my first go-to resources is a website called hifiengine.com. Okay, it's kind of a central point where they have put a lot of these things up. And you can see I'm on hifiengine.com. And if you go to their library, and you'll need to sign up for an account. It's free. It doesn't cost you anything. So you just sign up, you get an account, you log in, and you can download, I don't know, 5 or 6 manuals per day. It will allow you, and then it'll throttle you that you can't download any more manuals. They don't want you hogging all the bandwidth. But really, you only need to go on there to download the one you need for what you're working on. So if you go into the library, and you can see all the manufacturers out there, we have a Pioneer, right? So if we scroll down to the P section, and there's Pioneer, we click on that, and you can see they have integrated amplifiers, AV amplifiers, quadraphonic, and if we scroll down far enough, we'll find stereo receivers. We click on that, and there's all the different models, and what we have is an SX 3600. So we'll go to the SX section and we'll scroll down till we see 3600. And it's right there. Look at that. Click on that. And there's a picture of it. And you can see that's our unit. And it'll give you a brief description of what the amplifier is. So, for instance, if you scroll to the top, they'll usually tell you the year that it was made if they know it. So this one was manufactured between 1980 and 1981. And I don't know if this turning this off helps. I don't know. And you can see there's some data on it where it talks to you what the tuning range is. It has, medium wave and FM. It tells you that it's 30 watts per channel into 8 ohms, 10 hertz to 50 kilohertz. That's a pretty good frequency response for that type of amp. At 0.05% THD, damping factor of 35. Everything, good specs on this amp for what it is. And if you scroll down here, here are the links that you can download. You can download the brochure that you would have gotten at the store when you were looking at purchasing one of these. You can get the owner's manual that was included with the unit when you purchased it. And that might help you with recognizing what the connections with the knobs and all that are. So we can download that. If we click on that, and we'll put that in there. And then we'll download the service manual. Same thing. And let's just open this one here and see what it looks like. And this is the owner's manual. And if we scroll down and we expand this a little bit, and it flies off the screen, we can see item number 1 is that AM stereo output that we were talking about. This jack is for AM stereo broadcasts. When listening to the AM stereo broadcasts, connect the adapter component to this jack. So they actually made an AM stereo decoder module that would plug into that, and I've done a few videos on that. I used that Meducci module on a couple different things. We built a AM stereo encoder that would transmit an AM stereo signal, and even my Sencor SG80 is capable of outputting AM stereo. And yeah, that was a real thing back in the day. And actually there are still a few stations out there that are still broadcasting AM stereo. Now there are some out my direction, but they're just a little bit out of reach from where I live. So I can't tune them in from my house, but they are out there. So that's what that is. And really what that's going to be is that's going to be an output jack for the intermediate frequency of the AM tuner. And you could look at that on a scope, but again, we're not going to use oscilloscopes and things like that in this video. Now what we're really interested in is the service manual, which is the other document we downloaded. And what I will do is you can open it up on your computer and read it on the screen. For some people that's a lot easier. I'm an old-fashioned paper person, so I like to print things out. I can write notes on them. I can kind of look at them more closely rather than craning my neck looking at the monitor. I don't have to scroll around with a mouse to try to get to the part of the schematic I'm looking for, so I'll print them out. You don't have to, though. It's what's best for you, what you are more comfortable with. Now, as I've said before, I like printing them out, which is what I've done, and I only print out the pages that are pertinent to what I'm going to do. Usually, I have a large format printer, so I can print the 11 by 17 pages. So usually I'll print one page on the big paper with the schematic so that I can see it. And even with this, you can see how tiny everything is, but on a regular legal or letter piece of paper, you can imagine how hard it would be to see everything on there. Although it can be done, especially you younger folks with better eyes. I print out the spec sheet, which is usually the first or second page. If there's a block diagram and description of function, I'll print that out. It can be very helpful when you're trying to determine how the circuit actually works. And then always the adjustment manual. In case you need to get in there and check any of the alignments, these are going to be the instructions that show you step by step how to do it. Now when you get into tuners and so forth, you're going to see that you're going to need some test equipment that if you're a beginner, you may not have. So this might be something you'll want to skip. And honestly, unless there's a problem, usually these tuners don't drift on this generation of equipment. It's usually going to be the amplifier, the preamp, the tone control, the switches, the pots, things like that are what you're going to have to work on. And maybe capacitors that are bad, that are dried out, any number of things like that. Okay, but it goes through and shows you, how to do the output adjustment and all that. Here's a very nice printout of all the types of transistors. And I'm glad we downloaded this because this shows an example of something I've been looking for a while to show some of you. If you look on some of the transistors from the old days, there'll be these strange markings on the transistors, and some of them will have like a colored dot, either blue, green, yellow, or red. And those actually show you the HFE, or gain, of the transistor. And that's very important because certain parts of the circuit need a certain gain range. And yes, these transistors, when they were made, they were sorted by gain range. And that's part of how you match transistors. So these transistors, you could actually do a rudimentary form of matching just by buying the same type with the same gain range. And you'll find, and I've done this in my videos, I've shown you this in the past on some of my transistor videos. I did 2 I can think of right off the top of my head, where you can actually look up or select different types. For instance, the KSA 922s, there's a letter after the word 922 that tells you the HFE range, okay? And you can pick specific gain ranges, and it's almost like having a matched transistor. Now, it's not perfect. You still could use the little matching jig like I've shown you in the past, but it'll most of the time get you close enough that you'll get good performance if you have to replace them. Here's those transistors I was telling you about with only 5 legs, but there's 2 transistors in there. Okay, these are for the diff pairs, and we'll look at that on the schematic. And we go down the list, and we see all the different types of transistors. Very good. This is the one that I'm most concerned about, this 2SA726. A lot of the ones that Pioneer used back in their receivers, these 2SA726s, not the rest of these, but just these, had a problem with them where they would get noisy. They would either begin to hiss or they would get a crackly sounding in them. They would eventually fail. So usually when I see these in a receiver, I just replace them with a KSA922. I don't even mess with it. I get the KSA922 either from Mauser or DigiKey or Farnell or any one of the stores out there that sells components. And a KSA922, and I believe FBU is the suffix that you should get for it, will work very well in place of one of these. And I just, force of habit, I'll replace them. The rest of these I'll usually leave alone unless there's any problems with them. The rest of these are usually pretty good. Now looking at the schematic, we can see these input transistors. Here's your differential pair. This is the input stage. This is kind of a unique amplifier design in that the global negative feedback circuit, now this is a little more advanced talk for some of you, but the feedback circuit goes through the tone control and then loops back. And that's something pretty unique to this design. And in order to do that, all your gain and everything takes place in just these couple of little stages. So that can be pretty interesting, but it works. Careful component choice and design, and it makes it a lot simpler, so there's less things to go wrong. It makes it less expensive to make, and if you do it correctly, you can see you can get some very low distortion and still have very good results. Now, what that also will do is if something goes open in your tone control circuit, your feedback can go open loop, which is probably not a good thing, but anyway, that's how it works. Now these are the kinds of things you want to get used to, because you'll start seeing things that are common to all the different models of receivers that are out there. Even the more expensive ones will have concepts that follow this same thing. So working on these low-end receivers is very good because it takes away all the complexities and shows you just the basics of how all of these things work. Even if you had an SX 1980, and of course I did a video series on those, very complicated, lots and lots of boards and circuits and wires and whatever else, but it works on the same principle as this, with some upgrades and some differences. But if you can totally understand this, you will be able to understand that. So here's your AM and FM are separate, okay? So it shows it is very easy to look through here. And you can see this is your RF amplifier. Then you go into your mixer. Here's your oscillator. Mixer stage goes through your 2-stage filters, goes down here, and then everything's done on an integrated circuit on this. So they really shrunk the FM section down. When you look at it, there's not much to this thing, and you may say this is a cheap piece of junk. But actually, for an analog receiver, it's not a bad little receiver. It actually will perform pretty well, I'm pretty sure. So none of this stuff really fails very much. You're just not going to see a lot of problems. I think the worst thing that could happen is if a transistor maybe could fail, not usually in that section, or if a capacitor dries out and goes bad. Now, one thing of particular importance you want to look at in all of this old gear like this are these orange capacitors. Whenever you see these caps in 1970s vintage gear or very early 1980s, you'll see all these different types of capacitors in there, but you'll see some of them that are orange colored. These are made by Elna, and there are some other ones, but the Elna ones are by far the most common that you'll see. And these are special capacitors. They are low noise capacitors, okay, and low leakage. Usually when you see these, they are going to be in the audio path, meaning the audio, the sound that you're going to be listening to has to pass through these capacitors before they get to the rest of the circuit and out to your speakers. So if these capacitors fail or don't perform properly, it will affect the sound quality. Now, one of the things that happens to these caps is, even though they're called low leakage, they actually develop leakage. They develop high ESR. And I'm not going to get into great details about what all that is because, again, I did videos on all this stuff. Got a lot of watching to do, don't y'all? But again, if I were going to do anything by force of habit, I would at least replace these orange capacitors. Now, of course, we could do tests on it, and that would require test equipment, or we could just use our ears. And if to our ears it sounds good, don't bother with it, right? But if you do need to replace them, you could just use standard electrolytic capacitors, but technically they may not perform as well as the low noise. Now, a lot of people say capacitors are capacitors and it doesn't matter. Well, ask yourself this question: why would a manufacturer go through the trouble of inventorying and stocking different types of caps, like these black ones here and these orange ones here and so forth, if there weren't a reason for it? You know, these guys weren't stupid when they designed these things. They knew what they were doing. And even though this was a low budget amplifier, they still paid attention to detail. That was very important back then. And things like this did make a difference. And you would be surprised how much of a difference it could make. Now, again, you could put a modern cap in there. It would work. It would pass the signal, and the average person would not know it. And really, if you didn't have the right speakers or you didn't have the ear for it or whatever, you may not notice a difference. You may not care. And if that were the case, you probably wouldn't notice if these had a little bit of leakage in them as well. But the bigger problem is when these caps leak, they become less of a capacitor and more of a resistor. When that happens, anything that is connected through that capacitor, okay, that capacitor will prevent DC from passing between two nodes. So let's look at a place here where we may see something like that. So for instance, right here is one of those. It's 2.2 microfarads at 50 volts. And you can see it connects between the input of your differential stage of your amp and the input. This is coming off your volume control, which comes off of your signal sources. If there is a source of DC voltage somewhere, on your tape deck or whatever you're connecting to this, if this capacitor were leaking, that DC voltage would go right on here and it would change the bias of this circuit. Changing the bias of this circuit would change the offset between these two transistors, these push-pull, and that would put DC offset onto your speakers. That's how it happens. So those capacitors are relatively important, and so you don't want them to have leakage on them. So replacing them sometimes by force of habit might be a good idea. Now, some of these other caps in other places may degrade the performance of the unit, but they may not cause that kind of a problem if they fail. So here's another place where it's in the audio path. You have this one that's 10 microfarads at 50 volts. It goes down into the tone control section, which is part of your negative feedback. And there's another one here, 10 at 50. And a 22 at 25. All of these caps in here, okay, can affect your sound and the performance of this circuit. So when you hear about people recapping, that's a term that people just throw around anymore. And there's been so many arguments and debates and discussions and forums and everything you can think of. This is what everybody's talking about, you know, if it's worth it to replace these or just wait till they fail. Or should you test them? You know, well, it's a matter of economy, first of all. If you don't have the money, the talent, or the time, and the amplifier sounds okay, leave them all alone. If you want to try to make this thing last a long time, or you suspect that there is a degradation of sound quality or something like that, it might be worth going through and replacing the caps. Now, some people will only replace the strategically placed ones that are in the audio path, because these other ones don't usually fail as much. They hold up a lot better, but they can go bad too. Other people just wholesale recap everything. They say, well, for the handful of caps, you know, you're talking about $10 or $20 worth of parts, put them in for what they cost. They're pennies each if you buy them in bulk. Well, there's something to be said for that. I'll leave that up to you, what you decide to do. Now, for us, we may let this one ride. It depends on how it sounds, okay? Or maybe to do some demonstration, we will replace just the orange capacitors, because again, these dry out and they fail. And there's a high incidence of failure. That said, I've gone into a receiver that had these, and I've tested every single one, and not one of them has failed. I've had other ones where half of them were bad. I've had other ones where almost all of them were bad. And there's no rhyme or reason as to why. Okay? It could have to do with the, you know, the manufacturing date. It could have to do with the amount of use that the receiver had. It could have to do with the environment that it was stored in, whether it was in a wet basement or in a hot, dry environment. I don't know. I just know that these are the problem child of the amp a lot of times. So there's 1, 2, 3, 4, 5, 6, 7, and maybe a couple more around there, but you know, maybe 10 or 12 caps altogether, if that. So we'll replace them. So after all that talking, essentially what we're going to do is we're going to replace the orange caps, and we're going to replace the two SA726s. And I think this receiver will be just about ready to go. We'll check the controls, but they sounded very quiet. I don't think we will need to clean them. I've done videos on how to clean pots and all that sort of thing. I'm not going to repeat myself on that. So let's do that real quick. We'll replace these caps and these couple of transistors. All right, we've opened the bottom of the receiver, and we can see that it is very clean under here, and there's really no sign of any previous service being done to this, which is a great thing, because quite often when something gets to this age or even older, you will start to see signs of people going in there and working on things because they've had to make repairs, and then you just don't know what you'll be getting into. But if you look at this, this is what a typical factory unit should look like before anything's been done to it. And you will see some flux, you know, some of this around here, and that's normal. That's from the factory when they soldered it. You may see little bodge wires like this, and again, that's normal. That is a modification that was done during the manufacturing process in most cases. Now, sometimes if there's a burned track because there was damage, you could see a wire like this that was put in there as a repair. But this is actually a jumper that was made later on in production and made in the factory. So probably the earlier models may not have had that wire, and the ones made after a certain date did have that wire. Or perhaps all of them have that wire, and that was something that was added right after they designed and printed the boards, and they didn't want to have to change the board around, so they just added this as part of the manufacturing process. one of the things I'll do is I'll go through these boards, especially any of the big power things like pins where power wires are coming in, or if there's a transformer or a big diode or something, or a power resistor, and I'll check all of the little terminals in there and see if any of these solder joints ever got overheated and cracked. And you can see none of these really look very bad. As a matter of fact, they all look perfect. I don't think we're going to have to do anything. So that's good news. Now, another really good tool for working on these when you're going to replace components is a nice bright flashlight, and that is a pretty bright flashlight, because you'll see very quickly, if you look here, here's the capacitors we want to replace. 1, 2, 3, 4 right here. We want to do these, right? But the solder is on the other side of the board. Can you tell where it is? I can't. But what we can do is if we take our light and shine it in from the back, you can see, we can actually see where we are. And now what I can do is when I put my finger on that component and I flash the flashlight right on my finger, I know that I'm right in that area right now. Okay? So I can see most likely that capacitor is going to be somewhere around in here. And then I can start looking for the two terminals that would equal the capacitor. So if I go right here, somewhere around here is going to be our cap. Okay? Now, you've seen me use all kinds of fancy desoldering tools and things, and they're very expensive, and you don't need that stuff. Those are luxuries that are wonderful to have if you can afford them, but there are ways around it. The simplest thing and most effective will be solder wick, which is this stuff. I buy good quality stuff. You know, you buy the original chem wick. There is no-name stuff that you can buy on eBay. It works also, but this stuff really works well. It usually will have a little bit of flux infused in it. If not, you can buy some cheap flux and just put it on here to help. Another thing you could purchase is a desoldering pump, which is just a little vacuum pump that you can use. Or you can just use the pulling the loose tooth method. So what I'll do is I will go over here and I'll find my capacitor, and if it's too complicated in there, too crowded, I will actually try to I'll use my flashlight technique. Okay, and I will try to just heat up the cap where I think it is, and I'll wiggle it, and if it doesn't wiggle, then I know I'm not on it. And you may have to check a couple things out here before you find it. And there it is. See that? See it moving? I'll zoom you in. Tony and his camera work. Here we go. Am I on it now? Yep, kind of. Yeah. Okay. So get back on the cap. Okay. So what I do is I heat it up, and I'll wiggle the cap one way, heat the other end, wiggle it the other way, and just go back and forth like that until it comes out. And when you take it out, make sure you pay attention to the orientation of it. This one came out like this, with the negative terminal facing that direction. Okay, so I zoom you out. So the negative terminal was facing that direction. Now, on Pioneer gear, okay, they mark the boards. And you can see very clearly plus is on that side, so this side would be the minus. And that is in fact how this cap came out of there. On Sansui gear, it is very common, and Marantz, those two, it's very common for these to be marked incorrectly. I have seen it many times. I don't know why it's more common on them. I have never really seen a Pioneer receiver that was incorrectly screened. That being said, I'm sure somebody out there is going to tell me they had a Pioneer unit that was marked incorrectly, because I'm sure it's out there somewhere. I'm just saying I've not seen it. Treat every one of them, though, as if they could be wrong. Pay attention when you take these out, what orientation they're in before you remove them. Because guess what? You take this out and you lay it down, now you don't know how it goes back in. And if this is wrong and you put the new cap in backwards, it's going to pop as soon as you turn it on. All right. Remember we talked about these orange capacitors being special. And if you look at the bottom of them, see how they're shiny? They're like filled with an epoxy. And when you look at a normal capacitor, normal electrolytic, let's see if I have one laying on the bench somewhere. Well, here's one here. You can see they have kind of a rubber base to them. If it'll focus, see that rubber base? And that's how most caps are. But these ones will have this shiny bottom, and that's how you could tell these are those special Elna low leakage caps. Now this one's 1 microfarad at 50 volts. And I used to just automatically, anything at 4.7 microfarads or smaller, I replaced with a film capacitor, which looks very much like this type of a film capacitor. See it? 4.7 microfarad. I have since changed my mind, and these orange capacitors I usually will replace with the Nichicon UKL or KL series. So here's part numbers if you want to see. This is the 1 microfarad. I got these ones from DigiKey. But bottom line is, this is what they look like. And the UKL series are actually a low leakage type capacitor. They're the only ones really that Nichicon has that are kind of similar specs to these orange ones. Now, could you use the fine gold or the Muse series caps or whatever? Yeah, you can. And I have, and they've worked. But the closest match would be these UKLs. Now, of course, there's some other manufacturers out there that also make very high quality audio capacitors. But these seem to be the cheapest, and they seem to work as a perfect replacement. So that's what I use now. One of the things you notice is the lead spacing on these is not wide enough for the holes. So you could see what they did is they bent it like that. You never want to squeeze these apart, because that could damage the connection of the lead to the inside of the cap. So what I'll do is I'll take a little pair of pliers, and just like they did, I will take this lead and I'll just bend it down that way, and then I'll bend it down again this way, and that gives us the spacing we need, and that keeps it from straining that. And then all we'll do is we'll put this back in the way the old one came out, just like so. We'll flip it around and we'll solder it in. And again, we didn't use any fancy equipment, did we? Now what I'll quite often do is I'll get this thing centered in here, and I'll bend these leads out for right now. And I'll get one of them tacked in how I like it. Okay, so we'll get the solder, if I can find it, where I put it, here on my bench. And I'll tack this in first of all, till we get it where we want it. And this is optional. You don't have to be this crazy if you don't want to be. But this just does a little neater job. I will then go over here and I'll make sure it's straightened out, that it's, you know, in here the correct way. Make it straight. You see that? Then I'll flip it around without moving it. I'll snip my leads. And then I'll solder it. Now, why did I do it that way? Well, there's a couple reasons, and I overblobbed that one. There we go. The reason that I did that, and it's not necessary, okay? So if you want to put these in and snip them off, you go right ahead. But the reason I snip them first is whenever you cut these off, you notice these leads are tinned. So they're kind of a tin color, but if you look at the end where I cut it, you can see the copper. Maybe you can see it, maybe you can't. And that exposes, and technically that could be an ingress for corrosion, and the solder actually will fill that in on the end and prevent that. What's more, when that lead is sticking out like this, it actually acts like a heat sink. And quite often you can get kind of a crusty solder joint. You won't get that nice little cone on there like you're looking for. So that just makes it a little neater job. Takes an extra second to do it, but it's worth it. I just realized I didn't record that last thing. We did the next one, and it's all done. I used the cotton swab with alcohol, clean the flux off so it looks neat. And there you go. Now the next thing we're going to do is, if you look at the schematic, I've shaded in certain components with highlighter. And each of these things that are shaded in are those 2SA726 transistors that we were talking about. Now for those of you, that don't watch my channel and haven't seen a lot of my previous videos on this, this is one of the transistor types that is known to have failures. Pioneer used these little PNP transistors a lot in their 1970s vintage gear. And these transistors are known to get kind of like that snap, crackle, and pop noise. If you ever hear it, you'll know what I'm talking about. But essentially what happens is the leads of the transistors will get corroded just because of the type of material that they're made of, I guess. I'm not sure. And that corrosion will follow up into the little package of the transistor, and it will actually corrode the contact point of where the contact wires bond onto the silicon itself. And what will happen is it kind of causes a resistance in there, and the transistors will make kind of a hissing noise on and off. You'll be sitting there, the amplifier will be dead quiet, and then all of a sudden you'll hear like a crack or a pop sound, and it'll just randomly do this. If you put your voltmeter across the transistor, you'll see the voltage will kind of vary around. It'll jump around when it's sitting idle. And this is all characteristic of these transistors. Now, I'm not by any means saying every single one of these will always fail, but what I'm saying is a high percentage of them did in the past. And if you're going to do maintenance on one of these receivers, that would be a good thing to do, is to replace those. Now, the other transistors are pretty solid and we normally don't have problems, although I will say these I forget what these are, what part number they are. I think it's mentioned in here somewhere. But these dual package ones will also do that sometimes. They'll get noisy. But I usually won't replace them by force of habit because, of course, you have to kind of make your own pair and do a matched pair. We're not going to do that because we're keeping it simple on this video. But these two SA726s, we're going to do it. So here they are. There's one in the AM section of the tuner, There's 2 of them in the phono stage. They're the main output transistors for the phono stage. There's 2 that are the main output of your multiplex stereo for the FM section. So there's a total of 4 or 5 of them. 5 of them. So there's 1, 2, 3, 4, 5. Now that we've identified them, I just kind of went up into the unit itself, and if you see, I just took a little paint dot. I'll zoom in on one of them down here, you can see. And I just put a little paint dot right here. See that one? I don't know if I can get in a little closer without it going all foggy on you. Let's see. And here. See one right there? So I just marked them here and here and over here and here. So there they are. And we're just going to replace them with some very common KSA 992s. And you can see if you want to look at the actual part number. And you have to be very careful. These ones are emitter collector base. The other one, those 2SA726s, if I'm not mistaken, are backwards. They're actually base collector emitter. What that means is, you notice how these are kind of a D shape or a half circle? So if the original 2SA726 is facing this way on the board, these ones will have to face this way. You'll have to flip them around 180 degrees. And I think I actually have the little drawing. Yes, I do. So if we look, here's our 2SA726. And you can see base collector emitter. These ones are emitter collector base. So they're opposite. Now, that's another reason that I'm actually doing this. None of the transistors in here right now are making any noises that I know of, so they're still good. That doesn't mean they won't fail down the road, but this is a really good example of when you substitute a transistor. Electronically, these are a very good replacement or a substitute for a 2SA726. But as you notice, the pins are different. So just because somebody on a forum somewhere on the internet tells you that you can use these, that doesn't mean you just go right in and replace them as is. You still have to look them up and look at the pinout and look at some of the specs to make sure that when you replace it, that everything will be correct. So again, and I know I'm repeating myself, this is for a lot of you folks who are just starting out. So this transistor is facing this way right now. The new one will be facing this way, if that makes sense. So let me get this turned around, and we'll use the same method for these as we did for the capacitors. So we'll do some soldering again. And again, I'm not going to use any fancy equipment. We're just going to use the soldering iron and some solder braid where we need it. Okay, I'll see if I can get this on camera. This first one here we're going to do, and I think it is right over here. So we're just going to heat it up. And sometimes you have to get two pins heated up at the same time. And guess what? I'm not on the right one. Hey, it happens. Okay, so we're just going to heat these two up. And it comes right out. And there it is. All right. Now that's a little bit cruddy there. So if you have some solder wick, which I highly recommend you get, when we're done with this video at the end, I'm going to just line up the tools that we used for this entire job, or at least the anything beyond just basic hand tools, so that you can see the things that you need to get started in something like this. All right, and we're going to get a cotton swab again and some alcohol. We're going to clean that off. And I'm still in frame with my camera. Just like that. And now we're going to get our new transistor. And once again, we have the tape, because these are stuck on there with tape. And although it will sometimes burn off from the heat of your soldering iron, I like to take these with some alcohol and clean them off if it's particularly cruddy, just to get them cleaned off. And it just makes the solder joint a lot easier to make. So we have this. Now remember, we're going to flip this one around the other way. And let me get you back in frame. So remember, this one was base collector emitter. This one is emitter collector base. So the emitter is this pin right here. And if you notice, emitter is marked right there. So we're going to have to flip it this way. And it's going to go like that. So you can see it's the opposite direction from the 2SA726. Now, this is not a problem, but where you do get into a problem where the collector is not on the center pin, for instance. So let's say it was emitter base collector. Then the only way to make it work would be to twist two pins over top of one another. That doesn't work really well on this. I've seen people do that and put some heat shrink or some spaghetti tubing over the lead, but it's never very good to do that. So you'll have to find a different transistor that has the correct pin out. But now that this is in, let's flip it around and we'll solder it back in. We'll do this all real time here. We'll just get one side on there around the camera, like that. And then like I always said, I like to clip the leads. I'm just moving the transistor till it's straight in the socket or in its little mounting area. And then we'll snip the leads down. And then we'll finish it up, hopefully. And that's it. Looks good. And then we'll just give it another little clean with our alcohol. We should be good. So that one's done. And we'll go through and we'll do the rest of them. I'll pull one more out so you could see that process of removing it. And again, if you want, another method would be to use the solder wick while the transistor is still in place. So for instance, let me move you down just a little bit. So for instance, if we wanted to remove this one with the wick, we can also do that. Clean the tip off a little bit. And that comes right off like that. Like that. And like that. Okay, and that should pop right out. And there we go. Again, we'll get our alcohol, get it prepared, just like that. Clean it up. Get our new transistor, and we'll clean the leads off of that as well, just a little bit. And again, sometimes I don't clean the leads off. The soldering iron will burn it, but sometimes that glue actually gets in and you don't get a really good solder joint that looks messy. Okay, remember we have to flip this one around the other way. Put it in. Okay. And we'll get it started. And again, I'm doing all this way. You can also put the lead, solder it in and then snip the leads. That's up to you how you want to do it. Again, I prefer this method simply because it just gives you a little better result than if you have the lead on there when you solder it. But again, don't worry about it. Do what you like. This is your hobby. This is your project. That's what counts. All right. How's that? Not too bad. All right, so we have 3 more to do. I'll do those off camera. Actually, I will show you that there is a bracket in the way. Sometimes you're going to run into these kinds of problems. And what we're going to do is we're going to remove this bracket, which requires taking this off. And then there's 2 screws down here in the bottom that are going through the heat sink. So we'll take those out. Let's see here. All right. And then we got to take this little stabilizer off. Like so we can move the board. And then you have to kind of flex the board up a little bit so you can get this out, and then this comes out. Now hopefully we can reach this. Now if we can't reach, yep, we can reach them all. Sometimes if you're way up under here, you'll have to rotate the whole thing the opposite way and then look so you can look down into it. But I think in this one we'll be able to just do it like this. Okay. Again, we're going to use the desoldering wick. Here's another tech tip. If you're using this solder braid and you have some flux, either a flux pen or a little flux container or even flux paste, you can put a little bit of that on the soldering braid like this. Just put a little drop on there like so, and just shake it so it kind of spreads out there. And that's going to make it work a lot better. Now this real high quality Chemwick stuff has some flux built into it already, but it works even better if you add a little bit more. So it's just something to remember. And the transistor that we want to get out is up inside here a little bit, and probably this would be one that would be better to flip over, but I'm not going to bother with it. I think we can get to this one from underneath. And that flux just makes this stuff come off really fast. All right. And we'll pop that right out. And see, it comes right out. Okay, we'll put our new one in, same process. And let me clean it off. I'll shut the camera off for a second. We'll come back when we get this ready. All right, I just have the first lead tacked in. I'm going to straighten it out again so it looks nice. And I have my glasses off because this is up too close for someone with glasses, you know. I'll just do our little snip. And then we'll go in and finish soldering it. All right. And then I will show you the results here. See if we can get the camera under there to see it. And there they are. Right there. See them? Right up here. And that's how you do it. All right, we have those last two, and I think you get the point. When I get them in, we'll be right back.